Again, this is the video 8. This is the Posicast control journey, and this video will address PID control with Posicast, and this is the part 2. Okay, so we have seen before that we can use the Posicast control with feedback in several ways. In this video, we are going to use the Posicast control as a pre-filter, as you can see here. So this is the Posicast input control shaping. Okay, so this was reported in this paper that is referenced here. We can use the pre-filter using half cycle or 3 steps Posicast as it is expressed here for the 3 steps, and the PID controller can be this one with a filter in series. This is uses an anti-wind-up technique as it was described in previous videos. So I'm not going to speak about the gravitational search algorithm, but in this case the agents masses here represent each agent represents the control settings both for the PID controller and for the Posicast, and in this case the criterion optimization criterion was the integral absolute error as it is expressed here. So we can see here results obtained with a double pole system with a time delay. So the double pole is -1, the time delay is in 1 second. So the optimized Posicast half cycle is this one. So the first step is 0.7 and the second one 0.3, and this is the switching time. And we can see that the PID controller is this one. So here in the top you can see what is the advantage. We don't have this. This is without Posicast. As you can see, with Posicast, we got a less oscillatory system. Okay. In the control signal, we can see here the spike is for the second pulse of the Posicast. For this third order pole with a non-minimum phase, you can see that this is a non-minimum phase system. And also here we got the Posicast and the PID controller. You can see the benefit of using the Posicast again. We got also a fourth order with a time delay, and in this case this is a third 3 steps Posicast. This is the PID controller, and once more we got some benefits of using the Posicast. Okay, in this case you can see here the spikes from the Posicast control. Okay, so now the problem is how to deal with the model parametric variations, and the Posicast is very sensitive to model parametric variations. So in this study here we proposed a technique to deal with that. It's a kind of auto-tuning technique. So in this case, we also have a half-cycle Posicast and the PID controller in the same format. And just to show you how sensitive the Posicast is to parametric variation, we got here a second-order system with a time delay and with this parameter B1 and the time delay L1. So B1 is 2 initially, and the time delay is 1 second. And when we change the B1 from 2 to 1.5, this is the result if we don't change the gains. So you can see that in the red plot, the system becomes very oscillatory. The same thing happens if you change the time delay from 1. In this case, it was designed for 1 second, and we changed for 1.5 seconds, and once more we got the system oscillatory, as you can see here. Also for a second order system, in this case it is a third order system with a non-minimum phase 0 here. You can see that also when we change the parameter B2, this parameter from 1.5 to 2, the system becomes oscillatory, as you can see here. And the same thing with the zero, this alpha time constants. When we change for 0 from 0.5 to 0.8, this is a drastic change. The system becomes oscillatory. So what we have proposed is a technique that we have to have a model of the process. This is the process. GM is the model of the process. So we are going to compare the model with the process always, and we have this error, the error from the model. And based on the analysis of the error of the model, we may take the decision of retuning the system. To retune the system, we have to identify a model again using classical techniques, and then design or optimization techniques, and then design both PID controller and the off-cycle Posicast for the new model. Okay. So this was proposed in terms of simulation, and we can see here the difference. Okay, if you retune with the solid line is with the auto tuning, input shaping plus PID, and we can see that is, of course, it is benefits of retuning. So these are the nominal values here, and then for the GP11 and GP12. So there is a change in the values in this case of the control and the off cycle. It's okay. In the next video, I'm going to show you a practical application of this technique, an implementation with a laboratory electronic circuit. But for now, this is all. This concludes the video 8, and thank you for watching.